Example number 4, determine a sequence from a pattern. So in this example, they give us the first few terms and we need to find a sequence to determine the sequence. So this example is opposite of example number 3 and number 2 when we have a sequence and we find the first few terms. If we rewrite the first one, e over 1, e squared over 2, e3 over 3, e4 over 4, then the sequence determined by a fraction for top and bottom. So you know that 1 and then change it to 2, 3, 4, 5. Those are the variable and we will plug in n equal to 1 for the first one. So the bottom have to be n and this n is the variable, it will change. And e to the power 1, 2, 3 and it's similarly in the bottom. So we have e to the n. Now we check again by plug in starting from n equal to 1. In problem B, if we just have 1 over 3, 1 over 9, and 1 over 27, then we have 3 to the 1, 3 square, and 3 cube. So we have a fraction 1 over 3. 3 is the same number for the base and the exponent is changing. So we should have the variable for the exponent is n. If we plug in n equal to 1, we will get 3 to the 1, n equal 2, then we get 3 square, and so on. So if we just have from 1 over 3, 1 over 9, and 1 over 27. But the problem is we have the 1 in the front. Let's rewrite this 1 over 1, or I can write like 1 over 3 to the power 0. 1 over 3 to the 1, 1 over 3 square, and 1 over 3 cube. So our sequence is supposed to be for 1 on the top and then 3. We should not begin from n because if we begin from n, we will have 3 to the n. So we want to begin from 0. Then the n will have to less than 1 unit. So n minus 1. So if you begin from n equal to 1, you will have 3 to the power 0. Now problem C, we notice that we have from 1 go to 3, from 3 go to 5, from 5 to 7. We keep adding 2 to this. So we adding the same number many times, that is the multiply that number by an n times. And then now we plug in. If n equal to 1, we will get 2 times 1 is 2. If n equal to 2, then we get 4. If n equal to 3, we will 6. So 2, 4, and 6 compare with the number 1, 3, and 5. It is 1 unit less. So the sequence that we should have is 2n minus 1. So the next one, if we notice that this is 1 and then 2 square and then 3 square and then 4 square and then 25 is 5 square. I can write 1 in the front is like 1 square. So we have an exponent with the base is changing and the exponent 2 the same. So the base will be the variable and the exponent square. Now problem E, we will forget about the minus in the front. We can write 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Then the sequence we should have is 1 over n. With the minus alternate, you remember a problem. We go back to problem B before. We have the minus. This one, negative 1 to the n plus 1 determine the sign alternate. So if we have negative 1 with the n plus 1 power, we will begin from positive 1 and then negative 1 and then positive 1. So go back to our problem, we will copy the same way. So we will have negative 1 to the n plus 1. When we have the power n plus 1, we plug in n equal to 1, it will give us a positive number.